This is a worked example on how to solve a difference quotient. So whenever we're solving a difference quotient, we first want to identify the formula that we're using in the context of the problem. So for us, this will be this version of the difference quotient formula here. Some will be slightly different, but in general, they all work basically the same. Um, I have my function color-coded in green because I want to highlight a tip that will help with more difficult versions of a difference quotient. And that is that you should write out clearly what f of x plus h is. So we're kind of like filling in the parts of our formula before we go ahead and use it. We already know f of x, that's given, but let's write f of x plus h. And so whenever I have an instance of x in my function, I want to replace that instance of x with x plus h. So instead of just 2x, it'll be 2x plus h minus 5. Now let's expand this by distributing that 2. And now we have a clear definition of what f of x plus h is, and of course we know what f of x is. And so let's write this out. Well, let's fill in our formula, and you want to give yourself a pretty, decent amount of room to work with because the algebra can get pretty heavy. But I know h is going to go on the bottom. Then I know I have f of x plus h first, so let's lead with that. And then you want to be very careful here because we're subtracting f of x, but you don't just want to tack on a minus sign. You want to understand that you're subtracting the whole function. So I'll say minus, and then in brackets, I will write my definition of f of x. Okay, so hopefully the colors can make it pretty clear to see where f of x plus h is and where f of x is. But now let's just go ahead and drop those brackets, and let's actually see what the entire function is going to look like, or the entire formula, I should say. And so that minus sign distributes, I get minus 2x plus 5, and that's all over h. Now what you want to do is you want to look at what cancels. So, of course, if I have an exact same term that just differs by a minus sign, those terms will cancel. So the 2x and the negative 2x, those are going to cancel. The negative 5 and the positive 5, those are going to cancel. And I will just stop using the color coding, but what's going to be left over is 2h over h. And then this pretty clearly cancels into just being 2. And that is the solution to our difference quotient. Now, I just want to, a little bit of information. It's totally fine to have an answer to a difference quotient that contains an x or contains an h. Like, for example, a difference quotient solution could be 2x plus 2h. As long as that's what it simplifies to, then that's your answer. In a difference quotient, you're not trying to compute anything, you're trying to simplify. So don't worry if there are some variables left over in your answer. That's totally fine. The main idea here is we want to get rid of that fraction from the difference quotient formula and turn it into something that looks closer to our original function. So that is how you solve a difference quotient. Again, don't worry if you have some leftover terms in your answer, but in our case, it was pretty nice that it just ended up as being 2.